this is problem number 4 from section 9.2. In this problem, they say graph the solution set to the system of inequalities. So we're going to graph these. I'm going to use brown for the first equation, and I'll use red for the second equation. So the thing we want to do is we want to write these so it says y equals, essentially. In our case, we have y equals x squared minus 9. This is a quadratic. And this one here, we need to, it's a linear, so we need it to say y equals mx plus b. First step I'm going to take is I'm going to subtract the x for this problem here. And I get y less than or equal to negative x plus 4. And then I'm going to write this other equation out right here, which is y greater than x squared minus 9. And let's graph both of these. So let's start by drawing our coordinate plane. Now because this is minus 9, I'm going to have to go down 1, 2, 3, 4, 5, 6, 7, 8, 9 for that one. But these other ones I think I'm going to be okay with just doing 5. Okay. Now once we have that drawn, we can mark our y-intercept, which is, in this case, this is 4. And our slope is negative 1. So y-intercept is 4, which is here. And then we go down 1 over 1, down 1 over 1, down 1 over 1. And finally we'll finish there. It says less than or equal to, so that's a bold line. Not the greatest line that I've ever drawn, but it says less than or equal to that. We can again check 0, 0, so check 0, 0. When we check it, we end up with 0 less than or equal to negative 0 plus 4. So 0 less than or equal to 4, yes. Shade towards. So we're going to shade. I'm just going to mark it 2 arrows saying shade towards the 0, 0. Now for the quadratic, its y-intercept, this is basically the y-intercept. I'm going to call it that. This just means really though that we shifted it downwards 9. So although I'm saying y-intercept here, it's technically not the y-intercept, it just means we shifted it down 9. So we're going to shift it down 9. Actually, maybe we'll just write that. Shifted down 9. So we're going to go down 9 to right here. Now we need to figure out, because it's a quadratic, it's going to go be symmetrical on each side, so it's going to have 2 lines here. We need to figure out where some different points here that would be coordinates on the quadratic. The easiest way I think to do this is write this as an equation. Set the equation equal to 0 and find the zeros, meaning finding the roots. Where does this quadratic cross the x-axis? Well, we can add 9 over, so 9 equals x squared. We can take the root of each side, so we end up with plus and minus 3 equals x. So the roots are positive 3 and negative 3. And now we can draw our, this is a greater than, so it's not greater than or equal to, so this is a dashed line. But we can draw our parabola like so. And then it says y is greater than the parabola. So if y is greater than the parabola, I think that's going to be above here. So it's above the parabola, but it's inside the 2 arms of the parabola. We can check that by checking 0, 0. So we're going to say check 0, 0. So 0 greater than 0 squared minus 9, which is 0 greater than negative 9. Yes, that's true. Shade towards, which means shade towards 0, 0. So we're shading in here. So our solutions are going to lie wherever this green is, which is inside here. And that's how you graph the solution set for a quadratic and a linear.